Good morning, good afternoon, and good evening to everyone joining us from around the world. My name is Claudius Laskawy. I am an innovation manager at PlugAndPlay, the world's largest open innovation platform and one of the most active venture capitalists globally. I have the pleasure to moderate today's panel focused on hydrogen mobility and the opportunity this fuel of the future poses for the energy as well as the logistics sector. But before we get started, I would like to thank Dana and especially René Böhm for giving us the opportunity to host today's panel during the Startup Energy Transition Week. I think really you have done a tremendous job, and you and your team have really helped organizing a great format, and we really enjoy being part of it. Hydrogen has been one of the most talked about topics across all geographies and all industries this year. And it's really great to see so much interest in this topic and today's sessions, as this clearly underlines the urgency and the need for action around decarbonization and especially the mitigation of climate change. One of the biggest levers to help achieve the EU's ambitious climate goals is thereby the transport sector, which is why we focus on this today. And the transport sector accounts for roughly a quarter of the EU's total CO2 emissions. So we are really looking forward to hear more about potential solutions in this space. To better understand what is needed to achieve a carbon neutral transport sector and to learn more about what some of the pioneers of the large scale adoption of hydrogen are working on, I'm very, very pleased to welcome today's three panelists. Our first guest has dialed in all the way from Sydney, Australia, and Greg Knight has decades of experience, having held positions based in Australia, the US, Singapore, and China before moving into hydrogen as a co-founder of Hyzon Fuel Cell Technologies. Recently, he and his co-founders spun out Hyzon Motors, offering a wide range of hydrogen applications, and as recent as last week, announced French energy major Total as a new strategic investor. So what an exciting time to have you with us, and good evening to Sydney, Greg.
Thanks for having us, Claudius.
Our second guest also looks back on over 20 years of international experience within sales, marketing, and business development of commercial vehicles, and is today CEO of Hyundai Hydrogen Mobility, a Zurich-based joint venture between Hydrogen Motor Company and Swiss company H2 Energy, focused on the one hand side, putting fuel cell energy vehicles on the road, and on top of this, also securing the necessary refueling infrastructure to support them. It's great to have you with us. Thanks for joining, Mark.
Thanks for having me on the panel here, Claudius. Hello, everyone.
And our third guest is a true veteran of the energy industry. Jens Müller-Belau began his career at Shell as a fuel scientist in the 90s and has already held various positions within Shell internationally. In his last role, Jens was leading the Shell Technology Center, a global center of expertise focusing on research and development. And since 2019, Jens has been the head of energy transition for Shell Germany, overseeing Shell's initiatives in accordance to the Paris Climate Accord, and as well also developing new business opportunities in the space of renewable energies. Furthermore, Jens is also an advisory board member of the German national organization Hydrogen. So thanks a lot for being with us today, Jens.
Thanks for the invitation.
Sure. Jens, maybe we can get started with you straight away. For many, Shell is like a spider in the web when it comes to the energy transition. And you recently announced ambitious plans to invest heavily in offshore wind parks in combination with electrolyzers to produce new energies. Is Shell actually going all green now?
I mean, I guess we realize that the company as it does exist today, we need to transform into a different company. And overall, Shell does exist for more than 100 years, and we have a passion to exist for another 100 years. And realizing that we have to transform into a company that, at the end of the day, 2050 has the ambition to be a net carbon zero. We realize that we have to move away from certain businesses. However, from a global demand perspective, it is not that we tomorrow will not sell any fossil fuels anymore, but there is a transition from higher carbon intensity energy carriers to zero emissions energy carriers, and that will be a process over decades. We have started that journey a while back, but we see some first fruits specifically as well in the German market. I'm sure we will talk about this a little bit more.
Definitely. But let me quickly take one or ask one follow-up questions. Because since the topic is framed like transport and hydrogen in the field of transportation, so Shell has declared, as you just mentioned, ambitious plans to become net carbon neutral by 2050, which also includes not only scope 1, 2, and 3 emissions. So maybe you can dig a little deeper and explain to us what are actually scope 3 emissions and what role does hydrogen play on your journey towards becoming net carbon neutral by 2050?
Sure. So I mean, when Shell sets out its global ambition, we always talked about we want to reduce emissions, we want to eliminate emissions, and even compensation is part of the strategy. So when we talk about scope 1, 2, and 3, scope 1 and 2 in principle are emissions that we actually are accountable for based on our own production, and then scope 3, which we account into our own ambition, are the emissions that do exist when our customers actually use our energy products. So we account this as part of our ambition. So in terms of hydrogen, I mean, we as Shell, we had a hydrogen business more than 20 years ago. I often jokingly say we might have been too early, but we now feel since the last few years that the time is coming. So we have, for example, in Germany, we're one of the founding members of the H2 Mobility joint venture, which now I haven't checked the web this morning, but we do have actually through the joint venture 85 hydrogen stations live in Germany. We have quite an investment in California, where the overall market conditions for hydrogen are developing nicely, and I'm sure we touched on that as well, looking at this more globally. And then coming back to Germany, we actually are building the first electrolysis unit, which is the largest of its kind when it's live early next year, which is a 10 megawatt electrolysis unit in our Rhineland refinery. And we talk about 10 megawatt. It's a small starting point, because we need gigawatts of electrolysis. However, we need to start somewhere, and as I said, it's the largest of its kind when it's live next year, and hopefully will be overtaken quickly, because from a hydrogen business perspective and for the future of hydrogen, we need to get into 3-digit and gigawatt scale, hopefully fast.
Perfect. We'll come back to that a little later. Also, maybe the points where Shell is involved along the value chain of hydrogen. But Mark, let me involve you. We have seen many OEMs build prototypes, and Jens just said the time has come. So we really have seen a lot of prototypes out there in the past already, cars and trucks. And I remember especially some passengers cars being promoted as the future of mobility in the early 2000s. So oftentimes there were these big buzz events and showcase formats, and then nothing really happened. Why, from a Hyundai perspective, should it be different this time?
Well, Jens said it already. The time is right. No, I think seriously, I think the public awareness is a huge lever. We now really understood that we have some ecological issues, and that we need to tackle that. And that is true for all different segments in our lives. And so the public awareness helps to push that, helps to push the government. So also the government attention is now there. Hydrogen plays a much bigger role. I mean, you see hydrogen strategies popping up in every country, and there's huge funding behind that. Now we have regulatory aspects in place as well, also CO2 emission targets, which needs to be fulfilled as well. The cost structure is a different one as well. You must admit, because the prices went down significantly, and they will go down significantly as well in the future. So now overall, there's not only attention on the topic, but it's a commercially viable alternative now. So that's why I think it's a totally different situation than in the last announcements, I would say.
Speaking of commercially viable, 2 weeks ago you delivered the first 7 fuel trucks to Switzerland, and in a lighthouse project, I guess across Europe, where you got also a lot of media attention. And maybe you can walk us through the value chain of this project and also the involved players.
Yeah, sure, we'd love to. I mean, first of all, we have 9 vehicles meanwhile in operation, and by the end of the year, it's going to be 50. And then we're ramping up next year. So our goal is to have 1,600 vehicles in operation by 2025, and that's just Switzerland, right? The players in this segment are obviously in the hydrogen mobility. We get the vehicles from Korea, from HMC, from Hyundai Motor Company, where they are produced. We put a local upfit on here, and then we give it to the customer in a so-called pay-per-use model. That does not mean that means we do not sell the vehicles. We give it to the customer, and they pay a certain fee per kilometer, and that includes the whole operation, sales, after sales, and everything, and that includes the hydrogen consumption as well. Then there's another company, Hydro Spider. That's an important player as well because they produce the hydrogen here in Switzerland. So in this triangle between us being the manufacturer of the vehicle, the hydrogen production, and the refueling stations, in this construct, there is a clear commitment in regards to the quality of the hydrogen, the quantity, and also where it needs to be. The customers we are tackling right now are part of a hydrogen association in Switzerland, and that's where it all started. There are in this association operators of the refueling stations and operators of trucks, and they came up with a strong commitment to say, yes, we want to create this ecosystem, and we are willing to take trucks, and we're willing to build up the infrastructure accordingly. So that solves the chicken egg discussion in regards to what's first, demand or supply, because we grow together. So with the vehicles we're bringing in, the infrastructure grows accordingly, and that's the beauty of that.
Can this project become a role model for other European countries for cross collaboration?
To a certain degree, yes, and to another degree, no. Where it absolutely needs to be a role model, or is it a role model as well, is that we're not just saying we're the OEM, here's the truck, go have fun. It's really taking care in a holistic approach of the whole ecosystem, because that needs to be established and be built up in combination. That does not mean we have to do it all by ourselves, but we need to find the right partners on the hydrogen production and on the infrastructure side as well. So this joint approach of several partners from these just mentioned industry sections, they need to collaborate, including us, to really bring that into the market. Now, when I'm saying it's not just a blueprint, it's not a copy-paste, that is to a certain degree because in Switzerland we have other circumstances, let me put it this way. The diesel price is much higher here in Switzerland, so the benchmark we have to meet, we want to be on the cost per kilometer at the end of the day, is easier to meet because the diesel costs are much higher than, let's say, in Germany, for example. And in Switzerland, let's say 2 years ago, they installed a road tax where you have to pay a certain fee depending on how much kilometers you're doing and how heavy your vehicle is, and that is quite significant amount of money the truck operators have to pay here. And emission-free vehicles are exempted from that. So what we have here is more or less an indirect CO2 tax already, or a tax you do not have to pay if you're running emission-free. And that accumulates to quite an amount of money which we do not have in other countries. So that is the challenge. But on the other hand, with the strategies I mentioned, there's a huge funding out there, right? I mean, so the governments are willing to spend really significant money now. Somebody just have to tell them how to do that in a smart way, to set up a subsidy system which creates a system which is self-sustaining and probably even self-propelling, so that once the subsidies are gone, that system is still out there and can be utilized by the customers because they need the security for that.
That's very interesting. Have you seen any efforts from other countries to have some like similar subsidies, or even like the road tax, where the amount of taxes you pay will decrease in in accordance with the CO2 emissions that are emitted?
Well, I mean, the ambition to do something in that direction is basically there in every country. I mean, at least in every European country, I must say. And if you read the newspapers, it's fascinating to see how many countries in Europe want to be number one in hydrogen, right? So obviously number two is not a target. But anyways, there is huge ambition out there. Yes, there are thoughts in regards to, I mean, look at Germany. They want to have a CO2 taxation, and we're talking about, is it 25 euros per CO2 ton, or is it going to be 50, right? If you do the calculation and compare that to Switzerland, here we talk about roughly 1,000 euros per CO2 ton. If you factor both in what I just mentioned, the higher diesel price and this road tax. So we're talking about 1,000 euros per CO2 ton, and not about, is it 25 or 26? So yes, there are ambitions out there. Is it the right amount of money? No.
Well, but I think the amount is supposed to increase steadily over the next years, right? And that is going to hurt OEMs significantly. And maybe Craig, that brings me to you. First of all, thanks again for joining us at such a late time from Sydney. And you are somehow considered a new player in the OEM sphere. And if you look, or when I looked at your website, one can see concepts of buses and trucks. Are you planning to disrupt the OEM landscape?
I suppose you could say that to some extent, because you know, the incumbent guys always have pretty large innovators' dilemmas, right? So it's much easier to do something a little different as a new entrant, clearly. And naturally enough, having pretty deep intellectual property on the core PEM fuel cells, when we were scouring the market and talking to some of the incumbent players, and we realized the you'd have to call it resistance, certainly lack of proactivity and attentiveness to the idea of adopting PEM fuel cells as the primary drive, if you like, in the heavy vehicles. We chose to become kind of the master integrator of vehicles, so we can work with really well qualified component and sub-assembly suppliers to put these vehicles together, because the biggest kind of risk factor, if you like, in a fuel cell commercial vehicle is the fuel cell itself, right? So this is what we're comfortable with, and this is what we've worked with for many years. And, you know, we've got pretty decent experience deploying a lot of trucks, especially, mostly in China. And so we're now pursuing, you know, a launch process in Europe and North America, whereby we offer vehicles under our own name, and they are, you know, they contain our fuel cells and they contain other people's batteries and electric motors and so on. But this is not very different to how most vehicles are built today.
Perfect. So can you maybe give us a bit more background around where Hyzon came from? You know, you've been like in the industry for almost 20 years.
Almost 20 years. In almost 20 years in PEM fuel cell technologies, yeah. Wow. And around 5 or 6 years in automotive applications. I mean, actually, we did some of those early cars someone was talking about before, some of those early prototype cars and so on from 12, 13 years ago had some fuel cells in it from us, but that was all very much demonstration stuff. But in terms of genuine commercial vehicles to be deployed, you know, at some kind of scale, this is only really in the last 5 or 6 years. And this was greatly aided by the initiative in China for, you know, urban air quality improvement. When, you know, the big electrification drive, which has been running for decades in China, hit some limitations around battery utility, battery vehicle utility, then hydrogen got a leg up with some government support. And this was a great opportunity for us, because we've got operations in China, major operations in China. We were able to gain quite some experience by deploying our fuel cell powertrains into, you know, into light trucks, delivery trucks, and refrigerated, you know, food delivery type trucks, urban buses, and some heavy duty trucks too, port trucks, Class 8 prime movers. This sort of, the bigger trucks only started in 2019, but the smaller trucks started about 4 or 5 years ago.
Are you one of the big problems or challenges, obviously, for new entrants in this space is manufacturing, but also the infrastructure, the maintenance, and the repair. Are you also involved on that end, or are you kind of only primarily providing the fuel cell?
Well, obviously, if we're going to provide vehicles, we have to have a kind of holistic approach, right? Mark's already mentioned about the ecosystem to make it viable, and it's essential to have not only infrastructure for supplying fuel, but also infrastructure for supporting, vehicles and operations, right? So fortunately, there's a lot less kind of breakdowns and unplanned type maintenance with electric systems compared to mechanical systems, but still you need after-sales support. Now, one thing we're finding is that we're getting quite some support for companies that are part of the overall vehicle systems, whether it's distribution, sales, after-sales support, maintenance, and all the rest of it, because everybody that's in these activities now, they have these business models now, have a very finite future ahead of them if they stick to diesel systems. So we're getting quite some support from networks of companies, activity with these types of activities that can support our vehicles too.
Great. And Jens, maybe that brings me back to you, since Shell is running over 1,000 fueling stations in Germany, and you're obviously also part of the network, since you are the provider of hydrogen, and you also declared you want to become one of the leading suppliers of green hydrogen for the industry and the transport sector. So one part is, and that is also what Greg just touched upon, is the successful implementation of hydrogen charging stations and the network. Where is Shell playing in this field, and are you already actively contributing?
I mean, the question, where do we play in the value chain? I mean, we have the fortunate situation that we look at hydrogen as a very global product already. So we have each piece of the integrated value chain from really production, and production starts really with renewable energy, if we are honest with that, right? So down to the retail station somewhere, including as well logistics. We have with partners, we built the first liquid hydrogen ship to serve the project between Australia and Japan. So, but we haven't put everything in one market as a complete integrated value chain. So from a retail perspective, absolutely, yeah. In Germany, as I said, we do have 85 stations live, primarily targeting passenger cars. We would like to see more demand. And on the heavy-duty side, we are actually building heavy-duty truck stations in California. And I think one word that actually we often glance over, but it is an important one, it's about partnerships. Huh? And at the end of the project in Switzerland, we observe, which is a fantastic project, and you see similar projects developing in other countries, like, for example, the California project is as well very much about a partnership where the things have to line up, and you need a customer for all this, huh? Because ultimately there is an element that someone has to or wants to operate that. So I strongly believe that from that end of the value chain, as Shell, we know retail, we know customers, so that's actually good. And then if you dig further down in terms of electrolysis, I mentioned the Rhineland electrolyzer. We will build a 3-digit megawatt electrolyzer in the Netherlands, which again, it is about scaling up with speed. And what the basis for all that is in the Netherlands specifically, that we recently won offshore wind auction, where we are building offshore wind capacities in the Netherlands, and that direct connection between the renewable electrons and the electrolysis becomes more and more important. So I think it's an exciting area where it develops, and with the right partnerships, I think our objective really is to accelerate that, because time is ticking. and ultimately we can talk about what other alternatives do exist. But to be honest, we think that hydrogen actually has a sweet spot, which is not only relevant for mobility, but as well has reach into other industries that are very difficult to decarbonize. So we see hydrogen really much as a molecule that can integrate multiple sectors, and obviously mobility is a critical one, because that's very visible as well to the outside world.
Very interesting. Excuse me. We often hear of these various hydrogen projects being undertaken these days, and you just mentioned the Rhineland refinery, where you said you want to increase the green hydrogen output by a factor of 10. And you also mentioned the 3-digit project in the Netherlands, and then you do a feasibility study, I know, in H2 North, where we speak of 3 to 4 gigawatts until 2030. And then in the other projects, it's more like 100, 200 megawatts. So for many, these numbers are still hard to grasp or to put them into somehow of a context. What does that mean, 100 megawatts or 5 gigawatts? So I was wondering if you could maybe elaborate on these scales a little, and maybe also give an illustrating example for us.
Yeah, I mean, I will make it possibly by far simpler than it really is. So I apologize upfront for experts that are online and listening to that. But I mean, take the 10 megawatt electrolysis capacity in the Rhineland refinery. If we would run this at full throttle, so really 8,000 hours plus, and would use the entire output of that electrolysis as green hydrogen in trucks, with let's say with an annual mileage or kilometers of 150,000, that's about 100 trucks that you can fuel over a year. Again, give or take, round number. And then you just scale this up. I mean, one of the things which is most critical is to feed that 10 megawatt electrolysis, you need about between 2 and 3 substantial offshore windmills, for example. So the scale of the energy system, if we talk about gigawatt, you just multiply this now, and you end up with quite a large number of wind turbines or solar panels to actually produce the electrons, and then the conversion into hydrogen ends up then with as I said, 100 megawatt is about 100 trucks. Based on some basic assumptions, but again, give or take, but it is quite a substantial change of the energy system, which I think have to realize, and therefore we are celebrating projects with 3-digit megawatt, but what we really need is multiple projects that do talk about gigawatts at the end of the day.
So that really puts a bit better into perspective. Also, if we're looking at the total number of trucks being on the roads in Europe every day, how much is needed and how much scale is needed. So that's great insights. Thanks a lot.
Yeah, Mark? But before we move on, I just would like to step back. I mean, it's always easy to see this as, oh, that's scary, that's big. I think we need to turn this much more in the opportunity. And the belief is we need to decarbonize this planet, right? So that's the first belief. And as Shell, we take it extremely serious and really want to be an energy company in 100 years as well. So, because I think this scale can concern people, and that is a risk, in my opinion, because then you say, oh, too difficult, don't do it. But there needs to be some realism, right? So, I mean, it is, I think, very important that we balance that. It's a huge mega job for all of us. But on the other hand, not doing it has completely other consequences. So, and I think therefore, before, as I said, I didn't want to interrupt you, but let's not put this as scary out there. It is the opposite. It is actually a fantastic opportunity for a complete new energy system, and therefore as well a complete new business model.
That's great. Mark, I would like to come back with you as Jens said, it's a great challenge, but it's also a great opportunity. And We have also seen market players that have been betting on battery-powered vehicles or hybrid versions of battery and hydrogen-powered vehicles. So I know that you, as Hyundai, you have explored both sides, you have experience in the field. What are the upsides and the downsides of batteries versus hydrogen or fuel cell powered trucks?
Okay, yeah. I mean, the downside for both technologies are that we are spending way too much time to downplay the other one, from my perspective. I mean, like Jens said, we need to decarbonize the planet, so CO2 is the enemy and not the other one's technology, which is emission-free as well, right? So I think both technologies, it's not an either or, they need to live, or they're perfectly fine for, you know, living next to each other, and both have their reason for being. I think it depends on the sector and the application. At Hyundai, as you know, we're building small battery electric vehicles, and we're building passenger car hydrogen vehicles as well, and fuel cell vehicles. And on the trucking side, that's the only point where we say that battery technology has a disadvantage when it comes to the combination of payload and range, and also important for in regards to the refueling time. Because you do not have some kind of 350 kilowatt charging station everywhere, and if you have 4 or 5 of them to refuel, then probably you get an electricity problem, and that is quite a challenge. With you know, with fuel cell technology, you can easily refuel the whole truck in 15 minutes, and you're good to go. That's the beauty of that thing. So when it comes when it's about payload and range. And especially in the commercial vehicle sector, about refueling time, we just think that that fuel cell technology has some advantages over battery.
Correct. Have you ever considered combining your fuel cell technologies with batteries?
Every fuel cell electric vehicle is still an electric vehicle and uses some amount of battery. So definitely there's a little bit of battery in there, because batteries are excellent for dynamic response in the vehicle and for the capacitance that you need in driving, in typical driving cycles. Now, just like Hyundai, we're strong believers in fuel cells for commercial vehicles. We don't tend not to say range, we tend to say utilization. So range kind of implies you're going to take it out on a highway and drive 500 miles from where you start. That may not be the case. You may only drive 10 miles from where you start, but you may do that trip, 80 times a day. So it's all about utilization. If it's a heavy vehicle, as Mark says, if it's got a payload consideration weight-wise, and it's high utilization, it's very likely going to be hydrogen. That's the solution. We don't need to debate whether batteries are better or worse for some of these scenarios, because as Mark said, there are certain limitations that are natural in terms of utilizing pure battery electric vehicles, if you like. But there are many cases where a fuel cell won't be practical to kind of compete against a battery vehicle too. And there are many, we believe, many passenger vehicle scenarios where may never make sense to put a fuel cell into a lot of those vehicles, a lot of those usage scenarios. But frankly, again, going back to the point that Jens made right at the beginning about this whole decarbonisation imperative, it's not really a choice at this point. So everything we can all do to reduce the fossil fuel burn and take a little bit of revenue away from Shell, sorry Jens, but everything we can do to reduce that fossil fuel burn and replace it with vehicles that genuinely are zero emission is a good thing.
Speaking about like applications more broadly, we've been speaking before, and I heard rumors that you have some new projects secured recently. Speaking about like longer trucks, trains, or even aircrafts, would you like to show some insights around, or give us some insights of what you're planning currently?
That's for me, that question?
Yeah.
Yeah. Oh, sorry. Yes, Claudius, there is a little bit of news coming. We're not shy at the moment of saying that we've got some pretty good information recently from the third-party testing of our next generation fuel cells, which are going to be setting the benchmark in terms of power density. And these are fuel cells designed for commercial vehicles, so they are designed with a kind of 20,000 hour operating life in mind. And these power densities, which for a long time fuel cells weren't very high power density. They were under 2 kilowatts a litre and 1.5, 2 kilowatts a kilogram kind of power densities. There are now a number of fuel cells in the market that exceed 4 kilowatts a litre and 4 kilowatts a kilogram for power density. So now our latest weight optimized and volume optimized systems are over 6 kilowatts per litre and 5.5 kilowatts per kilogram at the stack level, which gives you a lot of flexibility in powering very large equipment, because you can fit a lot of power into a small design envelope, for example. So power density is a great enabler of this transition, because if you need a lot of power, then previously you needed a bloody big fuel cell, frankly, or a big collection of fuel cells that all had to work together with very complicated balance of plant with 10 different stacks, for example. So now we're preparing to launch fuel cells with a single module of 500 horsepower or 370 kilowatts in 2021. And this will enable a lot more applications, such as you mentioned, planes, trains, and automobiles, if you like. So yeah, a lot of high power applications are enabled through the general industry improvements in power density. But we're really very pleased to have confirmed the third-party testing results that we recently received on our new stacks. There'll be more information on this very, very soon.
Great. Looking forward to that. Is this, or last week you announced that you won French energy major Total as a new strategic partner. Do you like the synergies that you hope to leverage with the partnership with Total? Do these also accelerate these projects that you just spoke about?
Definitely, because we're out there talking to corporations and they have a desire to start reducing their carbon footprint, as has been talked about a couple of times here. And frankly, most of the hydrogen infrastructure is very suitable for a small car and very unsuitable for a large truck. So we need help from the infrastructure partners that we all need to have around us, Shell, Total, and others that are capable of bringing to bear the infrastructure that's needed for the large vehicles to successfully and quickly, as Mark said, quickly refuel.
Great. Mark, I have a last question for you, looking at the time. So you have had the first 7 deliveries of the action.
9, I think you said.
Sorry?
9.
All right. So maybe it's looking at the scaling part of the production and the deployment of the H2 Action fuel cell truck of Hyundai Hydrogen Mobility. Which markets, or you said you look forward to scaling it, but do you also look at new markets, other markets that you would like to target, and what kind of partners are you looking for these kind of projects?
Yeah, of course. I mean, we're not doing that just for Switzerland. I think Jens mentioned it before, right? We should not be scared of the big numbers. That's why we started in Switzerland. Now, we have a business case in Switzerland, but we get this question a lot of the times: why you start in Switzerland, and why don't you come to all over Europe or whatsoever? Like I said before, the situation in Switzerland is very special, in a positive way, very special. And we need to figure out how to create a similar situation, financially viable solution for the end user who has to pay everything in other countries. I mean, obviously, we have an aspiration to find other countries as well, or to find business possibilities in other countries as well, and decarbonize the transport in other countries as well. But it's a bit more difficult due to the factors I just mentioned. But obviously, we're not just here for doing what we do in Switzerland. I think there are other couple of countries in Germany, like Germany, like Norway, Netherlands, Austria, probably as well, who have really good ambitions in regards to getting this done. But the question is just how, like I said before. But again, there's a huge interest in that, huge appetite for that, huge customer interest. There are a lot of companies out there who are interested in the hydrogen production, in building up the infrastructure. And there is government fundings as well, and government strategies on how to, strategies that will push the hydrogen in general. Now the question is just how to bring that together, find the right partners who have similar ambitions and who want to, whose targets are the same. And then I think it's doable.
So Jens, how would you answer the question of what needs to be done within like the next 3 to 5 years in order to really scale up, on the one hand side, the production? I know you're doing a lot on that side, but also to create the demand and also to create like the infrastructure for hydrogen. Where do you see the biggest pain points or the greatest opportunities currently?
No, I think, the Switzerland example, I think Mark summarized it well. The economics do work in Switzerland, and I think for any other country, we will face that question: how you bring the partners together and incentivize in an appropriate form, knowing that you can't incentivize forever, right? So, let's be clear, we incentivize for the next 100 years and we happily live thereafter. It is more about really finding that mechanism for accelerating that growth. And that has to do with both sides. It's the production, but as well the demand. If you do only one, you actually struggle. And we've seen that, I believe, on the light duty side in Germany, where on the demand side, there wasn't enough appetite or enough in there. So it was quite difficult. And the vehicle manufacturers and those colleagues, they look into where do they position their initial vehicles, right? Because they as well have to ramp up their production. So, and I think that is a learning where if you find the right match between you incentivize demand appropriately and you incentivize the production, then you have a match, you grow, your cost will go down, and then ultimately you will have a sustainable business model. But that constellation possibly is really on a case-by-case basis, because each customer, and Mark quite rightly said it, it's about what application do you want to serve, and then you have to strike or you have to find that compromise. But it is about scaling up and therefore reducing overall cost to make this a viable, long-term, sustainable business model.
Okay. Interesting, thank you. Craig, maybe a question for you. As you are one founder yourself, and I know that we have many founders, startups, and tech companies in the audience today, where do you currently see the biggest potential for startups in the market environment, especially linked to hydrogen, but also renewable energies, new energies more broadly?
Look, I can't profess to be an expert across the spectrum of energy opportunities, that's for sure. We've certainly spent a lot of time in a well, if you like, in a very specific well around PEM fuel cell technology. So we haven't exactly been scouring the broader energy landscape for opportunity beyond our core technology, really. But we are absolutely delighted with developments in the last couple of years, because it wouldn't have mattered how hard we worked to make the incremental improvements on the efficiency and the extra little bit of power you get out of every square centimeter of your catalyzed, of your CCM or MEA, whatever in the stack. It wouldn't have mattered how thin you make your bipolar plates. Wouldn't have mattered how efficient your hydrogen recirculation and your air compressors are and all the rest of it, which we work on every day. None of that stuff would have mattered if the external factors didn't line up to support the adoption of the technology, right? So I think that to a great extent we see an opportunity, as an entrepreneur, and then we try to follow that opportunity, follow our nose. Sometimes takes an awful lot of patience and a few kicks in the teeth, but at the end of the day, I think the persistence to go after it, if you really believe in it, hopefully it'll be worth it, and hopefully it'll be worth it for us too. But there are many opportunities right now, quite clearly, in the hydrogen sector. In a broad sense, everything from production technologies to storage, transport, delivery, all sorts of stuff around mobile storage, on vehicle type storage and all the rest of it. There's a lot of obviously opportunity within subsystems of electric propulsion and everything that goes with that, because fuel cell vehicles are fuel cell electric vehicles, right? We've got a whole electric vehicle to think about besides the fuel cell itself. So there's much innovation that will happen within these systems, including a reimagining of vehicle systems in our view. So we believe there'll be a reimagining of some of the materials and some of the construction methods and some of the fundamental designs you have in vehicles, because you no longer have the mechanical drivetrain to accommodate, and you don't have to have chassis systems that accommodate that that design. So we think that there's many opportunities, but we're not an expert in the whole ecosystem, but there are many opportunities with this amount of tailwind on hydrogen, and as is evidenced by Shell and Hyundai and their commitment to hydrogen as a key enabler in this energy transition. There are many other companies that will be on similar journeys, right? And it's frankly a lot easier for a small innovative company to disrupt, mature businesses and markets. It's much easier for small companies to disrupt, actually.
Perfect. So thanks a lot for all of you for joining us. Unfortunately, we have to come to an end here now, as our time is up, and I've already stolen, I think, 4 more minutes. But we all started a bit earlier. So we are really happy to continue this discussion across the various formats that we as PlugAndPlay have planned for the coming weeks and month. And I know Craig's going to be with us next week again during an event we are hosting in Northwest Arkansas. Feel free to reach out to us at PlugAndPlay if you would like to be part of the discussion around hydrogen, or if you would like to be part of our ecosystem of over 400 corporate partners, among them being Hyundai or Shell, and then also the tens of thousands of startups or young tech companies like Hyzon Motors and countless government agencies. I would like to, if you would like to learn more about the related topics during the Startup Energy Transition Week happening now, we'll have, or our Ventures Director, Olivia Told, will be part of tomorrow's Impact Investment panel starting at 12:45 p.m. And you can learn about the PlugAndPlay ecosystem in a masterclass with our director, Salah Faridi, also tomorrow starting at 1:30 p.m. And with that, I would like to thank you all very much. It's been a great pleasure to have you with us, and I learned a lot. Goodbye, stay safe, healthy, and looking forward to being in touch with you soon again. Bye.